what you're looking at here is an original schematic from the original picture from the instruction manual for an ST35 build back in the day, original Dynaco. And what you'll notice here is the output transformer, right? The Z565, which are the kind of famous output transformers. If you come down here, the yellow wire coming out of it goes to 16 ohm, the orange wire goes to 8 ohm, and the black wire goes to kind of the common here. So let me take you here and show you what I've done. Alright, exact same thing here. I've came out of here with the orange wire and gone straight to the 8 ohm lug. Came out of here with the black wire and went straight to the common. And I came out of here with the yellow wire, which should go to a 16 ohm jack. And I put it to where the 4 ohm jack is. And what I'll end up doing is just I'll end up putting something over top of this to say that this is 16 ohms and not 4 ohms. And I did the same thing on the other side, and boy, some of these old transformer wires, you can see down in here black. I mean, it's hard to tell the difference between orange and yellow, but I ended up scraping a little of it off, and you could, once you did that, you could tell what color was kind of hidden underneath all the age or whatnot. But nice and neat. Check it out. I mean, you got right out of the transformer hole straight into these lugs, right out of the transformer hole straight into these lugs. You know, we still got more wires here to hook up on either side here, but slowly but surely we're getting there, and this amp's coming to life. We've got the this other side. All these are the input sides to the output transformer, and I'm betting money that red there, the same as this red on the other side. I bet those are the plate, high voltage plate winding there. But we'll figure it out as we go along, and the rest of these will probably solder up to these tube sockets in various places on these boards. And similarly, the other side of this power transformer here, my guess is these leads here feed off, and or one will go to one side, one will go to the other, and they're probably 12 volt windings or 6 volt windings to feed the output tubes, is my guess. But we'll figure that out as we get a little further into it, for sure. Up next, I round another black cloth wire from the input black of the transformer down here to the fuse holder. What I'll end up doing is coming in through this hole with you know, the three colors of the power cord. One will go here, or the hot wire, the white. And I'll run the black over here to this lead, and then I will run the green, the ground, over here and tie it onto this lug right here. And that's how the power connection will do. I'm probably going to make that my very last thing, just because the power cord kind of gets clunky with holding this thing on the workbench or whatnot. But I thought I'd show you where it would go, and that turned out nice and neat. All this old cloth covered wire. It's one of those things I couldn't build new amplifiers using cloth covered wire, not for resale. It's just not against up to current UL codes, but for something vintage like this I'm restoring or fixing or personal item, it's absolutely the right thing for me. It looks great. Alright, I found this diagram online, pretty neat. It's original Dynaco ST70, the original layout with all the you know, the original multi-can cap and diodes, all this discrete kind of point-to-point power supply, which we've now replaced with this nice little unit under here. But the thing I liked about this picture is somebody actually went to the trouble of color coding the wires here, so helped out a little bit. So we've got the green and solid and the green and white coming over here, and if you'll notice, they go to pin 4 and 5 of V3, which these are the 6 volt heater winding is what they are. And then if you'll notice from 4 and 5 here, there's a set of wires that go up here to number 4 and 5 on V2, second tube. These are the 26BQ5 output tubes. And then if you'll notice, it feeds from 4 and 5 here off and comes over, and one goes into pin number 5 here, and the other goes over and feeds pin number 3 here. And let me show you something on the other screen over here. This is the pin out of a 7247, and what's basically happening is they've tied 4 and 5 together on that little PC13 board. So you're basically making a connection to 9 and 4 and 5 together with 6 volts. So it's 6 volts across here, 6 volts across here, heating the two different sides of the 7247. And what I've done here is I've ran the white and green wires over here, and I've soldered them to pins 4 and 5 on this one, and then I've used some blue and orange hookup wire that I had, and I went and I twisted them together and fed over here to the pins 4 and 5 of these tubes. And then, as you can see, the same blue and orange hookup wire, another twisted pair here, came up fed pin 5 here, or connection 5 and connection 3. If you notice, connection 3 here ends up going to pin 9, because this is upside down: 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you'll notice, this lead here goes over and it feeds to both pins 4 and 5. That trace goes on through there. So that's how you're getting the 6 volts between both sides of that tube there, all being fed back off the original 6 volt AC wires coming out of the power supply. Got to do the same with the brown and white, but it's not quite long enough, so I'm going to have to extend these wires somehow. Okay, we've got this one done. If you'll notice, the wires feed out. I ended up splicing them, used some brown and white wires here. Let me get these others out of the way so you can see. Fed up to pins 4 and 5, the 6BQ5, fed from that with some twisted wire here to the pins 4 and 5, and then left that and back to socket number 5 here, which feeds these two pins, and over here to socket number 3. So nice and neat and clean. I'm liking how it's turning out. And it's bright and early Christmas Eve morning here. Still working on this thing. If you can see, I've soldered in a couple of the resistors at this point. And I've got these cloth wires here with the green and stripe and blue and stripe soldered in, much like the schematic here shows. So basically, I've installed the blue and white and the green and white up here. And this is where it deviates from the original. In the original, the green and white goes over here to pin 9. What they're doing is they're having you move the green and white over to pin 8, which is a non-connected pin inside of this tube, and then they're just using it as a jumper point to feed a 100 ohm resistor over to pin 9. So basically just putting a 100 ohm resistor in series with the green and white wires. So we've added that 100 ohm resistor. There's also some 1K resistors between pin 2 here and pin 8, and before that was just a single solid wire that went there. Did the same here, and I got ready to do this one, but I realized I needed to hook up the blue and green wires here. And I came over here and I started looking at these two wires, and literally it is impossible to tell which is the blue and which was the green. These things have faded that much over time, and I studied and studied and could not come up with what was what. So I started down an interesting path and spent about 10 minutes on it, and came to realize something quite unique here. So I'm going to break that part out, and it's a part around testing the Z565 output transformers. I'm going to break that out as a separate video today. So just jump out of this video, watch the other one. I'll probably upload it first, to be honest, and then it'll bring you back to this, and you can watch the completion of this build. Just hang tight, it'll be up. Okay, after our little side excerpt video that was worthy of its own production, I'm back at it here. So we've gotten the, kind of the blue and white and the green and white wires soldered up here. We've got the 100 ohm resistor in place, the 1000 ohm resistor. Here we've got the blue and white soldered in place, the 100 ohm resistor and the 1000 ohm resistor in place. By the way, one little tip: soldering these old cloth wires, the metal itself inside these wires is not the easiest to get soldered to adhere to. A little bit of liquid solder flux, it goes a long ways in helping getting a good connection. But I've got these all soldered up well. Similarly on the other side here, we've got the green and the blue soldered here, the 100K resistor, the 1000K resistor, the 1000K resistor here, the 100 ohm. If you'll notice, these were not long enough, so I had to make some wires. So I didn't have any blue and white striped and green and white striped wires, so I just used some white wire, but I put on here glue. I used a green shrink tubing and blue shrink tubing, so I know which went with which. And we got all that soldered in. The other thing I did was the plates on this thing come out of here, and they actually go up here into the power supply board, into this section called C244. Let me see if I can find the right paper here. I've got so many schematics going on this thing. Here we go. So if you'll notice here on this thing, there's a set of leads here called C244 right here, and that would be those two. And the wires that feed out of C244 ultimately end up feeding over here and going into the output transformer, the red here, and ultimately the other one feeds all the way down around here into the red, which is the plates here. And TS1 here, if you'll notice, TS1 coming out of this thing feeds over to the transformer, which we've already done earlier the other day. So really what we've got left here are these 4 ground connections that we've got to make, and then way hidden underneath here is kind of the cathode, left cathode and right cathode. The ones labeled right here, RC and LC. We'll have to feed those over. They actually feed down, around, and they connect to the cathode wires. So we'll have a little bit of jumpering and connecting of wires to do here with those. And then just a few other connections. This one here, C23, will feed down here to number 5, and it'll jumper over here to number 5. So this document helped a lot with tracing back to the original schematic and how to wire this thing up. But we're going to get it going now, moving on along pretty well. Okay, as I continue to trace back and forth between this schematic, kind of the actual schematic, physical layout, and a PC13 set of board schematics, I finally slowly figuring this thing out. But one thing I realized is that since this power supply I put in this was designed for the SCA35, and yet the output boards I'm using are intended for the ST35. There's a whole board here, a whole section that's not being used, PC11. So any of the connections feeding to this board are actually not needed. So you can see here, this connection here is not needed. This one's not needed. The hum pot one's not needed. And so I've gone in here basically on this board and I've put a little X over everything that was not needed there. It's actually all 3 of them. And then like C23-2, I finally figured that out on the schematic here, that point is right here, and ultimately ends up feeding up to what would be hole number 5 in the PC10 board. But since I'm using a PC13 board, that same exact spot feeding up is actually spot number 7. So I ended up coming out of this C23-2 and feeding to hole number 7, as you can see here on both boards. Let's see, what else have I gotten done at this point? Oh yeah, from hole number 4 here to hole number 10, and number 4 to number 10 is a connection that has to be made. Up next, I've got the cathode bias sockets in here that I'm going to have to solder to. And one of those will actually feed over here to pin number 3 of this output tube, and then I'll feed from this number 3 to the other number 3. Similarly, out of that one for the right over here to pin number 3 of this output tube, the cathode, and then I'll have to make a jumper connection from pin 3 here over to pin 3 here. And then you'll get your bias voltage from that socket right there. And then there's just a few ground points that end up coming back off of this that I'll have to get to. And then you've got like socket 1 here and socket 2, which if I'm not mistaken, I haven't dug it out yet, but they end up going to the inputs here. So just a little bit more to go, and we're making progress. Okay, used some orange cloth covered wire, fed out of the right cathode lead, right over here to pin 3, made a short jumper of wire, fed down to pin 3 of the lower tube, and we've got that in place. Yeah, you can see my wiring. It's not the neatest on this earth. I've never been, I'd love to do beautiful, you know, aesthetic wiring, but mine tends to turn out to be more functional. Okay, we've continued on down the path. We've got 7 connected here. Let's see, we've gotten the negative feed, the yellow wires which I fed here, which come up here and go to number 6. Those are the negative feedback loop that ultimately feed here off of the 16 ohm tap. I've added a little connection here from pin 8 back to 11, which is another part of the negative feedback loop. Basically comes off the green wire. Similarly, I've done the same thing over here on this side. Actually, I haven't. I'm glad I caught that. I gotta go do that. So there's ground wire down here to the common. Similarly, a ground wire from here down here. This thing basically creates a star ground point for everything, and then you end up grounding that to the chassis itself. So looks like I got one more little wire to put in over here, and that goes to number 11 from pin 8 here. And then I think from there all that's left is up here 1 and 2, and 1 and 2, which are actually going to feed into the inputs here. And I've got some nice silver braided wire we'll use for that, or shielded wire. Okay, I've got some braided Teflon coated silver wire here, and this stuff is a pain to work with, I'll tell you that much. It's really hard to get the outer sheath off. Once you do, the braid is really tight around the inner connector, about like a piece of coax. You have to kind of braid that apart one little strand at a time. And then you get down here to the other end and you go to strip off the Teflon from the inner coating, and it's kind of almost made into the wire. It's a little bit tough to get off, but we finally got it. So this one will end up mounting up in here, you know, to go from like right along in here from the center connector. Okay, we got the silver Teflon wire in here, soldered the center lug into the center here and the outer to there. Ran it down here, brought the center to pin number 1 or jumper number 1, and took the shielded wire over here to number 2, and that connection and that one are the same, so if the wire happens to touch at some point. And these things are a little further off the board than it appears, so they're not any chance of touching. Similarly over here, number 1, number 2, and we've got the connection here. So I think we've got this thing pretty well soldered up here in the ready to go. Well, I still got to hook the power cord up. Here's what I'm going to do. I'm going to let this thing sit overnight, and I always like to, when I get something done, I never plug it up right away. I always kind of walk away, get a clear head, come back the next morning and walk through it from one end to the other to double check to make sure we got all the connections right and we're not missing anything. It's just a safe way of knowing that you kind of got it all. And not the prettiest stamp, but it is neat and tidy. I did a fairly clean job of all the cabling and soldering. You know, I've seen much prettier jobs, people that are good at breadboarding and whatnot, but as far as being fully functional, I think this thing will hold up for that. So I'll set it down and check it again in the morning. And one more tip here as I'm cleaning up the workbench and just putting stuff away, getting it out of the way. You can see all these little scraps here of, oh wow, lots of little wire ends that I cut along the way, and lots of little pieces of wire here. At any rate, underneath my desk here, I keep a box. It's just nothing more than a priority mail box that I taped up at the top. Basically an empty box, but I like to hold it right here under the edge of the table and sweep all my stuff into it here. Works out quite well. It's lightweight, and I just leave it under the workbench. And if I need to throw something under there, I can. Helps me keep a clean bench going. Stay tuned. We'll be back tomorrow after we check this thing out a little bit. I decided to go ahead and wire it up tonight and then let it sit overnight. Check it in the morning, then power it up. But I thought I'd go ahead and get the power connections here wired up tonight. A couple things you're going to need. You're going to need an IAC power cord. Just a 3-prong cord here on one end looks like that. The other end looks like this. And let me tell you the best source of these. Go to your local Goodwill. They're used on tons and tons of equipment, and people donate these to the Goodwill all the time. And Goodwill sells them for $2 a piece. It's about as cheap as you're going to get them, and I buy them anytime I get a chance. Keep a good stock of 15 or 20 of them. And what you're going to do first is using the handy dandy cutter here, and see if you can watch what I do here. I'm going to leave as much length as I can to it and say goodbye to that end. Just made it into the garbage can. At this point, what we're going to do is use the strain relief here on this, and we're going to get it in the socket here. And I've got a tool here. It's a Hayco number 29, made specifically for squeezing these little strain reliefs and then pushing them into the socket. So let's get that out of the way. You can kind of see what I've got going on here. I've got it squeezed in here. Got this thing held down, and you'll just end up pushing this thing in until it kind of locks in there, but I can't do it one-handed. I'm going to have to put the camera down for a minute. And ta-da! It snapped in there good and tight. And what do we have now on the other side here? We've got our 5 or so inches of cord left over. Let me show you, let me strip them and I'll show you where they're going to go. Okay, we've got the power cord in, and the blue wire on this one corresponds to what would normally be a white wire in a cord. I don't know why a lot of these computer cords use European color standards, but they do. But blue would be the white or the hot wire, which feeds over straight to the switch, straight off of the switch, then over into the fuse, out of the fuse, into this tap here, which then feeds one of the cloth wires that goes to the primary of the transformer. The brown wire, which corresponds to the black wire, then feeds into this tap, which then feeds into the other primary of the transformer, and the green wire comes down here. And I accidentally nicked this green wire when I was stripping it, the outer part here, and so I just threw a little bit of heat shrink over it instead of cutting and losing 6 inches of cord. And then I brought that down and I tied that to the ground lug here. So I think we're in pretty good shape at this point in time. Like I said, I am going to go on to sleep now, and it's Christmas Eve, about 6 o'clock, and you know, when Santa shows up tomorrow, maybe he'll bring me a new set of tubes for this thing. At any rate, we're going to go get some rest and get back at this thing maybe tomorrow after some of the festivities here at the house, and look over it really good, make sure I haven't missed something, making sure I hadn't got the wrong colored wire in the wrong place, make sure I don't have any missing wires or something. I just like to go through it with a fresh set of eyes, and then we'll get this thing powered up for you to see and listen to. Alright, I went through this thing about 6 ways from Sunday, and everything looks good, everything looked right. I did find one thing. Pin 2 here on the chassis here needs to be grounded. So on an original Dynaco chassis, the outer part of the RCA jack here is actually mounted to the chassis. On these newer style jacks, they're kind of floating, so without grounding that, you've kind of got this whole input jack kind of floating, and it ultimately ends up driving the tubes kind of really hard out of the gate. So I swapped an email or two with the guy about these boards and was asking some questions, and he kind of pointed out that those things needed to be grounded, so I did that. It was just simple as running to that common ground point here, a wire over here and a wire over here. But let's go ahead and turn it on. And we're going to let it warm up for a little bit. I'll be back. I'm not seeing any sparks flying or smoke or loud hisses or noises. So I'm going to let it sit on for probably 15-20 minutes. One thing I will say here, we've got this part, and let's see here what we're getting. We're supposed to have 0.27 volts here, and we're getting 0.23, 0.24. It's still climbing up as this thing's warming up. So let's let this thing warm up for 15 minutes or so and get kind of quiesced at a good warmed up operating state. And by the way, these are 4 brand new tubes, so, or 6 actually. So a little bit of break in here won't hurt them either. I thought it was kind of interesting in the boxes rolled up around the tubes. They gave a really nice spec sheet here, basically the same thing you would find in an RCA tube manual. You got the pin out, and you got your voltages, currents, plate resistance, everything's here. The only challenge is I can't read any of it. It's all in in Russian, so I'd have to look it up in the RCA manual anyway. But I thought it was pretty neat that they included that with the tube. You don't find that much with American-made tubes. So, we're up here at 0.27, bouncing around just a little bit. We're going to let it stabilize out here, and we'll be back. It's been about 20 minutes now, and we've got it warmed up. You notice we're sitting at 0.266, 265 on one channel here, and over on the other channel. Similarly, they're both, the way the instructions tell you to do this bias is this enhanced fixed bias setup. It's basically you adjust for 0.27 volts on average between these two, but these two are sticking pretty close together, probably because I have matched output tubes. I'm going to get this thing down to like 0.27, right in there. Maybe just a little lower. This thing's really touchy. See the slightest movement of my hand. Takes this thing, let's see, 0.27. 2710. Let's go and check the other one. Love these little test leads built onto the board. We're at 2706, 2708. That's close enough for any. They're both basically at 0.27. Tell you the heat sink here on this thing's nice and cool. Tube's putting off a little heat, but nothing bad. You can tell they're running nice and cool. Nothing. Not throwing out tons of heat. Certainly no red plating or whatnot. And the amp's dead quiet, to be honest. I don't hear any hum at all. So let's see here. See what we can get going here. Thing's sounding amazing, and like I said, dead quiet with it unplugged as well, with no audio going to it. Let's hook it up and do some testing on the analyzer. Okay, we're coming out of the output here of the 8903, the audio analyzer. I've basically got a 0.2 volt signal coming out of this. Feeding over up into basically the output of this thing feeds into this switch here, which does a lot of things. One, it can either feed it to a dummy load. I've got a 8 ohm 200 watt non-inductive load that I can flip between listening to it on speaker or on the dummy load. Same thing on the right channel, speaker or dummy load. And then I can choose which output, left or right, I'm sending over here to the oscilloscope. But check out the nice little sine wave there. The thing's just perfect. And when I switch to the left channel, it doesn't even blink. It's the exact same pattern, exact same amplitude. Thing is doing a great job putting the exact same amount of signal out. If you'll notice right now, I'm running at 0.06%. I'm got it on distortion here, 0.06% distortion. Couldn't ask for anything any better. I can jump it up to, like, let's say 0.4 volts. See here, my scope jumped way up. We can bring that down a little bit. Get a little easier to see. But even at a 0.4 volts of input, still only 0.11% distortion. Amplitude here, if we go to 0.5 volts, that is full line level. So I mean, that's being driven pretty darn hard right now. And still only 0.15% distortion on this thing. And we've got 1.9 volts on the output. But if you'll notice, my output to the oscilloscope here is a 1/10 output. So instead of 1.9 volts, that is a little bit bigger signal than that, probably more like 19.2 volts. Pretty interesting here. Things driving pretty darn good, to be honest. Okay, we're going to try this thing on the Peak Millet software here, and basically start this thing up. It's going to come up, and I can hear a tone in the background. Reference level okay, and this thing's going to plot across then, and we'll see what it does. This is a frequency response. So we'll see what we get out of this thing. And we're sweeping all the way from 20 hertz here all the way up to 30 kilohertz. And man, is that thing impressive. I mean, you got just a little bit of degradation here all the way up to about 100 hertz. I mean, just the slightest, like 0.2 dB down, and then you're pretty much flat all the way out here till you get, up here around 8, 9, 10K, and you drop just a hair. As we're getting here, into the 10K range, even at the 20K range here, we're still only down like 1 dB, as you can see here. So I don't think that's bad at all. That's super on the output for this thing. Okay, the very last test I'm going to run here. So I'm still 0.11% distortion. Extremely low. Got it running up here on the HP3582 spectrum analyzer, and as you can see here, I'm on top of the 1 kilohertz, and there's absolutely no other noise, no other signals. See if I can get to the next range here. Yeah, that's at, let's see what we got here. Way off scale. I mean, you're talking about 576 millivolts here on this little peak, compared to, we're so far off scale it can't even measure it at that point. So, yeah, like I said, there's not even much of a glitch here to even be seen. Total peak here, we're at about 4.8 volts, so this thing's absolutely beautiful. Really happy with how this thing, let me turn off some of these things, how this thing's turned out. As far as a good solid audio amp here, the ST35 is kind of hard to beat. And if we take this thing back off the dummy, before I wrap this video up, just a few more things to show here. One, I've had people ask me where I got these tubes from, the 6N14N EBs, which is labeled that way, but they're actually 6P14P-EB. So let me show you up here. This should help you out some. So just do a search on eBay for 6P14P-EV. Make sure you get the -EV, not the -N, because the -EV are the equivalent to the EL84 M's or 7591s. So they withhold a much higher current drain. So definitely the ones to get. And here you can see a matched quad for $44. They will ship from the Ukraine. Takes about 3 weeks to get them, but you know, I've ordered quite a few and had no problems. Matter of fact, there's a guy here that has you know, 50 of them all matched, same date code for $5.99. I've been considering buying a bunch at one time. Anyway, thought I would show you that. Just had someone ask me last time. And the last thing to show you and let you hear it. Sounds amazing. Good jazz. So you can see the amplifier now. Nice black Dynaco. Looks just like a Dynaco ST70. Unsuspecting looker would think that's what this was, because I think these are ST70 style chassis, exact same size, exact same shape. Added the nice little Dynaco label I picked up somewhere along the way. And you can see the nice blue boards on the inside here. I think the thing looks great. Underneath of it here, I put on some nice little black rubber feet on this thing, and it sits nicely, sounds nicely. Overall, I'm really happy with how this thing turned out. It'll be another nice amp that I throw on the shelf. Have no idea what I'll do with it, but it'll definitely go into the collection. Again, everybody, thank you so much for watching these videos. This is going to be a long one, so I'm thinking about maybe breaking it into 2 pieces. We will see. At any rate, hope you had a great holiday, and we'll be back soon with some more videos. Thanks again for watching.